Welcome to Eminent Scholars Academy. In today's class, we'll be looking into this very simple question from 2021 GCE, that's for private candidate. A particle of mass 2.0 times 10 to the power of minus 4 kilogram moves with a velocity of 300 meters per second. Calculate the associated wavelength of the particle. Given that h equals to this, 6.6 times 10 to the power of minus 34 joule seconds, h here is called the Planck's constant. So how do we go about solving this? Which formula are we going to use to solve this particular GCE question? In 1924, the French theoretical physicist Louis de Broglie, he gave an hypothesis which we call the de Broglie hypothesis. The Broglie hypothesis is basically under the duality nature of matter. Matter having a wave-like properties and a particle-like property, but its own aspect, its own support is on what? Matter possessing wave-like property. In a very simple way, what does the property the hypothesis talks about? The hypothesis is basically on the fact that every matter possesses wave property. And in a very simple term, the de Broglie hypothesis, the Broglie hypothesis is every moving particle will have an associated wavelength that is proportional to its momentum. So this is the formula here. Every moving particle will have an associated wavelength that is proportional to its what? Its momentum. This is it here. That is, the wavelength is inversely proportional to what? Momentum. The moving particle here could be light, it could be photon. So in this case now, this wavelength is often called the de Broglie wavelength. So the constant of proportionality here is going to be our Planck's constant. So whenever you see this formula here, is from what? The Broglie hypothesis. Wavelength equals to Planck's constant over momentum. So how do we apply it to solve this question here? Do not forget this momentum here is linear momentum, not our angular momentum. So linear momentum here is the product of mass and velocity. That is, we can rewrite this as wavelength equals to Planck's constant over mass times velocity. Plugging in the values that we have there. So when we plug in the value, that is, the wavelength becomes the given Planck's constant 6.6 times 10 to the power of minus 34 over the mass, which is 2.0 times 10 to the power of minus 4, multiplied by the speed, which is 300 meters per second. When we punch our calculator for this, we should be having approximately 1.1 times 10 to the power of minus 32. Wavelength is a distance, so the unit is going to be meter. So this is the answer to the question, 1.1 times 10 to the power of minus 32 meter from the Broglie hypothesis. Thank you very much for watching.